Okay, so now that we've kind of done vectors, we're going to deal with negative vectors. So vectors basically going in the opposite direction. So, and what's going to make the vectors go in the opposite direction is basically just their angle. So when we're multiplying a vector, it just becomes longer. So, and we multiply each individual part of it. So both components, the x component and the y component, would be multiplied in order to extend the lengths of a vector. So when we're dealing with this magnitude-wise, you would first find it's the Pythagorean theorem, a squared plus b squared equals c squared, where magnitude's your c squared, or your c, not your c squared. That's why we have the square root, to get rid of the squared part of it. And you'll multiply it by 3 afterwards. So if you see here, they're exactly the same. You can take the magnitude of your regular vector and then multiply it by what we're multiplying afterwards, or you can do it either way. Either way, you're still going to end up with the same answer. Just for review on how to simplify a square root, you would do 90, and then you would end up getting you would factor it out. So you cross this out because you already factored it. This is a 3 and a 3. Since we're looking for squares, we're looking for a pair, so we have a pair of 3s. And we're just left with this 2 and this 5. So the pair goes outside. The leftovers get multiplied inside. Obviously, we broke down the 10, so there. So that's how they got this. Just for a quick little review on square roots. And if we need to find the angle, because everything's proportional, you'll end up with the same angle. So even though the components, the x component and the y component, are different, if you do it with tangent, see how it reduces, that -9 reduces, because if you're multiplying both of them. So this is what allows us to multiply fractions top and bottom by something, is just proportionality. Let's take a look. So calculating. So we're multiplying it. More practice on multiplication. So let's get into an actual problem here. So if we want to do k times our vector, first we need to find the magnitude of this vector. So I'm just going to find the magnitude first. That way it makes it easier when we're doing all of these afterwards. So by finding the magnitude, I'm going to do 2 squared plus 5 squared in the square root 5 plus 25. And I'm going to get this square root of 29. All right, so k multiplies. Oh, and they want us to, oh my gosh, they actually want us to do all of them. All right, so we're actually going to have to use, I use Desmos for my scientific calculator, because I did not realize that they actually want us to do it. So this is vector v, and we're just going to multiply all of these by it and get our answers. So we're going to do scientific. Oh, no, not graphing. Scientific calculator. Come on. Now's not the time to go slow, internet. Okay. Perfect. So, all right. And first one we're going to do is the 2.5. So 2.5 times square root 29. We get about 13.4. So we're going to try to find one that has that 13.4. So that's going to be this one. And then because we already have the graphing calculator open, this makes it a lot easier. So now we're just going to multiply this by 4, get 21.5. So we're going to drag this over here. Then we're going to do the 0.3. So this 0.3, we get 1.61 and or 1.62 apparently after rounding. And then we're going to do the 0.8, which is 4.3. And we're going to do 0.5. It's 2.7-ish. Or it does have 2.69. And then we're going to do 5.2, which it should be the last one, but just to do it, about 28. So, boom. And that's all we're doing when we need the magnitude. I mean, the reason why it was so much easier doing it the multiplying way, like factoring out the k, was because this was the same, so it's able to fix it. Otherwise, you would have to solve for the magnitude for each individual one, and that just doesn't make any sense to do it that way. Moving on, let me erase the screen. So if we have a vector k, that's all this is proving, is that you can just take the magnitude and multiply it by k afterwards. So multiplying with negative vectors. So here's our vector. Before multiplying the vector by anything, it is handy to calculate its attributes. Then, see the product vector, find the direction. So we want to find the direction. So that's going to be tangent. So tangent to find this vector's direction. So we're going to want to do tangent inverse of y over x. It's opposite over adjacent. Opposite is always our y value. So our y value in this case is 5, and our x value is -3. And luckily, we already have Desmos opened up. So we're just going to do function tangent inverse 5 over -3. And we get this -59. -59. I'm just going to do it to the nearest ones place. And find its magnitude. Okay, so we need to find the magnitude as well. So we are going to do the square root of -3 up for the exponent plus 5. I guess I don't need parentheses. 5 squared. This is going to equal the square root of 9 plus 25, which is equal to the square root of 34. I'm just going to leave it at the square root of 34. Submit that, and we can see all the work that we did. That's exactly the same. They square rooted it. I'm just like, it's still a number. It's always more accurate to have it this way, but this is a lot more useful. Multiply v by the negative scalar -4. So this one we're literally just gonna do. I don't know why they're having us do this. Like, we just proved that it works, but we're gonna do -4 times. I guess this would be a good part in actually doing that. So otherwise, I could have just plugged into the calculator anyways, but whatever. So we're gonna do -4 times 5.83. 23 negative 23.32. Oh, they wanted us to actually find the vector, not the component. Wow. You know what? And it even says component form. That was totally on me. So let me redo that one. So we're just going to do -4. And the vector was -5, -3 and 5. -5. So this is just going to be 12, comma, -20. All right, and then find the direction with the magnitude. So in order to find direction, we're going to do tangent inverse again. Tangent inverse of a fraction, and that's going to be -20 over 12. Again, it doesn't matter if I would have used the original or the magnified one. So let me just do this. So tangent inverse. Oh, but we already have that. Oh, but now it's the signs are different. Well, they are and they aren't because they technically switched. All right, so that should still give me the same. Oops. I don't know why I thought that was a calculator. So it should end up being the exact same thing. So we're still going to get the same magnitude. The magnitude has not, or the direction hasn't changed, which to me is very, very strange. It should change. Oh, you know what? It does change. Or does it? I'll plug it in. I think this is going to tell us that we can't multiply both components by it. -20 over 20 over 12. Yeah, it's still the same thing. So we still get that -59. I'm just going to leave it at -59. And it also asked us to solve for the magnitude, which I totally forgot. But we can look at that here. We're just, um, they just multiplied it afterwards. I mean, we already solved for the vector, so I don't know why they're showing us that they're multiplying it afterwards if we already did it. And we get this number right here, this 23.32, which is 4 times more. I think I did it by accident somewhere else. Compare the magnitudes of that and this. So if we're looking at these two magnitudes, it should be 4 times more, and it is. So magnitudes are 4 times greater. What is the relationship between them? 4 times greater, but it is in the. Well, I can't even say that because it ended up being the same thing. Because of the fact that the negative and a positive, it looks like it ends up being in the same direction. Compare the directions. Well, if you compare the directions are the same. -59 degrees and -59 degrees. So we're just going to say the direction are the same. It should be opposite, but we're still getting that negative angle. Comparing the difference of 180. I don't know what it's asking here. So upon comparing the angles of direction, the difference is 180. I don't know where they got that. Angle -4 degrees. angle of V. I don't know where they're getting any of those numbers from, to be honest. Compare the directions. We calculate the directions and we got this. I feel like Edmentum does not do a good job explaining this, and I don't know what they're looking for because here's the direction, vector line. Oh, duh. So I don't know why the way Edmentum sets it up, it always sets it up in a weird way. You have to use your common sense in realizing which quadrant this is when we're thinking about the angle. So whenever you're doing trig or vectors or whatever, keep in mind which quadrant it is. So if this is a positive and a negative, that means that we're talking about quadrant 4. So we want our angle to end up here in quadrant 4 somehow. So the only way to do that is by doing the 360 minus our angle. So make it end up here. So actually it would be 360 plus our angle. So that's how we can compare the angles themselves. I just feel that Edmentum does a terrible job at setting up how to find the directions because it sets this up and like, oh, but also keep in mind this. So they should really format it a little better. What they're basically saying is if we do all of that work, which honestly doesn't make any sense because they didn't have a solve for it over here, if we do the work and compare it, we'll find that because it's negative, they're in the exact opposite directions, which is what I was initially going to put, but based on how they're answering their questions, it's very weird. All right. And then what does the angle comparison make in part E tell us? Um, so angle comparison, they are they are facing opposite directions. So I find that their series of questions is very weird because this one, what we would say right off the bat is like, hey, they're facing opposite directions, but they want you to say that it's 180 degrees. So they want you to say that they are 180 degrees apart. So we will have to redo the top ones. I'll go over them in a bit. And then this one just says that they're in opposite directions. Suppose you did this, suppose without performing a scalar multiplication, predict the magnitude of the vector. Suppose your observations from the earlier examples. So, do we have a vector u? Oh, there it is. Yeah, vector u. Oh, wait. I think I skipped part G. I'm sorry. Nah, now investigate the attributes of this zero vector. That consider the new vector this. Okay, so I didn't realize they were giving us a new vector for part G. All right, so we want to figure out, find the vectors, angle and direction and magnitude. Okay, so let's find the magnitude first. So the first thing we're going to do here is find our magnitude, which is a square root of the squares of our components. Plus -2 squared. This is going to equal 16 plus 4, which will give us square root of 20, which, since they've been wanting us to solve for, Let me actually solve for square root of 20. 4.47. So we have that. That's our magnitude. And then it wants us to find our direction. So finding a direction, we are going to use tangent inverse. So tangent inverse of y over x. So we're going to do -2 over -4. And that's going to give us an angle of tangent inverse of 1/2, basically. So that's going to give us a positive 26.56. Now we have to keep in mind that it's a negative negative. So this is going to be in um, quadrant 3, which means we have to do 180 plus 26.56. So I think I mentioned in one of the videos all late and everything after I made all my mistakes. And it's just something you have to keep in mind when you're doing this unit is you will have to bear in mind what quadrant you're in to solve for the angle. So the reason why I knew to add 180 is you do 180 plus the angle and you'll end up in quadrant 3. So our answer is going to be 206.56. 206.56. Submit that. And yep, there we go. You can see right here that they're adding the angle. I really wish they emphasized it a little bit more. And I solved my magnitude early, apparently. All right, so suppose now, without performing the direction check and everything, what would we do? So we're just going to multiply this by a half. So for cutting this in half, our magnitude would be 2.235. So that's just 4.47 cut in half. And the direction, we're going to want to be 180 degrees different from this. So we're going to do 206.57 or 206, yeah, 206.57 minus 180. So this one minus 180, we get the 26.56. They're a little off because of round off error, but for the most part, we're there. Now carry over the scalar multiplication. They want us to actually do the scalar multiplication now. So they want us to do, I'm just gonna start doing the solving for it right now. For the magnitude, just because it just makes sense to do it right now. What's our vector? Our vector is, what's vector u? Vector u, vector u. -4, -2, -4, -2. 4. Parentheses, it's bugging me. -0.5 to 2. So this will actually give us our component thing. So I guess I should have just calculated the component first. So this would be 2. Other 2 come from? So that would be 2 squared plus positive 1 squared And then this will end up being 4 plus 1. So we end up getting the square root of 5. And the square root of 5 is 2.24. 2.24. Rounding. So there's our magnitude, and it's actually what we got. And the next one is it wants us to find the direction. So we're going to have to use tangent inverse. Tangent inverse. And our vectors were our y value turns into a 1. So it becomes 1 over 2 equal to 1 over 2. Where is 1 over 2? So 0.5. 26.57. 26.57, which again, those are the exact same answers we got. So it's just a little bit redundant doing this. Do your results match? Yes, they do. What can you conclude from the results of obviously what we've already said a few times? And then let's see what else we got here. All right, so next one, same thing. We can just multiply it afterwards. Now we've just proven it. Um, Negative direction, so it's going to be 180 degrees difference when we do this, which I think this is a really bad example how they set it up because it's the same angle. But you would have to adjust it depending on your thing. So because of the fact that it is in the quadrant, we would know that we would have to add 180 to figure out what this angle is. Going to the next thing. So there's also, you always do your angles from here. It just makes it a little easier, and you have to pay attention to your quadrants. All right, so let's go to this one. So this one, they want us to find the magnitude and their direction. So let's take a look here. So first, let's find the magnitude before multiplying it. So we have square root of -3 squared plus 5 squared. So we have 9 plus 25. So this is square root of 34. And they want 2 decimal places. So what I'm going to do is I'm going to leave it as a square root of 24. And then I'm going to multiply by 0.5. Otherwise, it just gets a little weird. So I'm going to go in here. And I'm going to do. Is there a clear? Clear all. Okay. Is it negative or positive? Negative. Negative 2.5 times the square root of 34. So we're going to get negative 14.58. Negative 14.58. Your magnitude is always positive. So that's like on my new, it's going to be a negative answer because we're multiplying by a negative. And let's see here. Direction. So what direction is it going? So in order to do that, um, oh yes, I'm so sorry. Um, so our components will be this one you can solve for the vector itself. It might even make it a little easier. It doesn't. So let's just find the direction of this vector, and we know it's going to be 180 degrees from there. So if we find that, we're going to do tangent inverse of 5 over 3. So clear this out. Tangent inverse of 5 divided by We have 59.3 degrees, and we want it to be 180 away from there. So since it's in quadrant, this angle is in quadrant 1, we can just add 180 degrees to make it the exact opposite location. So that's 0.0494 and 2. So 249.4. So 249.0404. All right, and Desmos is just being mean at this point. This is why I don't like um, what they're doing. So I'm assuming what they did was they want you to solve this first, which is annoying. Um, so they want you to do square root of 34 first, and you're going to get that 5.83. So this should be 5.83. You're going to multiply that by negative 2.5. So there's just so much room for round off errors that I can't believe Desmos doesn't do. 5.83, 5.83 times negative 2.5. You're going to get negative 14.58. Negative 14.58. I don't remember what I said the answer was last time. And for this one, let me just do it how they might want us to do it. They're going to want it to be 5 times negative 2.5. When you take the test, hopefully they're a little bit better with the numbers. 5 times negative. Oh, that's stupid. Oh my gosh. 5 times 2.5. All right. 12.25 negative negative 12.25. That's going to be our y component, and our x component is negative. This calculator is stupid. Why would you put the negative afterwards? Negative times 2 times negative 0.25. Oh my gosh. Well, that's just going to be positive. Oh, so it's 7.5. So we have 7.5 comma negative 12.25, and we need to find the magnitude of this, bearing in mind that it should be in quadrant, so positive and the negative. So because it was negative positive, it should be in quadrant positive negative quadrant 4. So let's do this. What is it? Tangent inverse. It's just annoying because I know they're going to be small errors. You know what? I'm just going to populate the answer because I know they're smaller. Yeah. See, I think this was off by like 0.01 just from round off error. This one, I'm pretty sure we got it right. It might have been off by like maybe a little bit. So they're just round off errors that you just kind of have to deal with, unfortunately. When you take the test, let me know so I can see like how far off your answer was if it was a plug-in answer. All right, but moving on from dumb things that don't account for round off error. So subtracting vectors. So when you subtract vectors, when you added vectors, all you would do would essentially be uh, go from here and then tack it on. When you're subtracting vectors, so you can see how they're doing it here. Here's the vector, and then you tack on the new vector, and that's going to be your vector. However, when you're subtracting vectors, it's a little different. You're kind of doing it in the opposite direction. Here's a chart for obviously doing inverses, which is weird, but they're reminding us how to do that. And I'll leave this for part. We're almost done. Never mind. I was like, I'll leave this for part 2, but we have like 4 slides left. So considering these vectors, subtract them. Subtract vector v from vector u. Okay, and this phrasing is very important. So we're going to do this. I'm just going to handwrite it in, and then we'll look at the answers. So subtract vector v from vector u. So we have 2 minus negative 3. And then we're going to have negative 3 minus 5. So we end up getting this negative 1. Or, sorry, the negative and negative is a positive. Positive 5. Come on, wake up, Victor. And negative 8. So that's going to be the resulting vector. And then because we cannot represent subtraction with vectors on a plane using this, find the inverse, which is that, use scalar multiplication. So we're just, literally the inverse is just making them negative. So the inverse of v, so if it's negative 3 and positive 5, it's literally just going to be positive 3 and negative 5. That's all we're doing for these inverses. All right, add those vectors together. So it's just saying that if you just do the inverse and stuff, you're going to get the same thing. So if you add those vectors together, you're still going to get that 5 and the 8, basically, because this is subtraction. You're multiplying it by that. So it's a subtraction. So you're still going to get 5 and negative 8. All right. Compare the vectors, that and that. They are the same. This is like basically just algebra concepts. I don't know why they're like super spelling it out for you. Add a vector for its negative part, write the resulting vector. So we're doing it with the inverse, which means it's just going to be 0, 0. Because the x component cancels out with its negative x component, the y component cancels out with its negative y component. So we're just going to end up 0, 0. That I don't even think we need to work. I don't understand how Edmentum can do all these like complicated stuff, and it's like this is basic. All right, so last one. Based on your answer in part E, what is the relationship between them? They are in opposite directions. Opposite direction. They even use the word opposite directions. Cool. All right, moving on. Ooh, I don't know why all my writing's here. Uh, so the way we would do vectors is essentially we just add the negative component. So instead of like moving this vector from this initial point to the terminal point and then putting the initial point of this to this terminal point, you're going to do that, but you're just going to do the opposite vector. And that's going to give you this vector right here when we're subtracting. So this is what caused a lot of the velocity vectors in the first 3 videos and the videos in those to look all weird because of how subtracting a vector affects it. All right, moving on. Oh my gosh, Edmentum, why do you do this to people? All right, so they want us to do the sequence of this. Okay, this is at least a sequence. The other ones were ridiculous, where it's like rank all of these. What do they want us to do? Vectors in order. So, oh no, it's still really bad. But we'll do it. It's Shouldn't take too long. All right, so they want us to basically subtract b. So this is going to be negative. Oh, and they still want us to do the magnitude? No, Edmentum, I'm sorry. So I don't want you doing all this work because Edmentum needs to stop. This is ridiculous. Like rank everything by the magnitude? No. So we're gonna have to like add them together and then do the magnitude because that's the only way they know how to put the answers in. I'm just gonna click answer key. I'm sorry, Edmentum. Like that's ridiculous. So they do the resulting vector, then they find the magnitude. Even they're not showing all the work. They know there's a lot of work and they're not showing it because they don't show how to calculate the magnitude. They're not showing the addition steps. So this is all here if you need it. All you're doing is doing that. Here's a sequence. This is dumb. Like I don't think you're learning anything. It's way too much work to get this. This it was gonna take like at least 20 minutes to do. So those are your answers. You can take a screenshot, or this video is going to go up like as soon as we're done. All right, and then just watch the summary video to kind of get an idea of the negatives and positives. So I know I kind of skipped a lot of the work, but it's just a lot to do, and I feel like they're simple steps. We know how to find the magnitude. We know how to add a vector. Those activities should kind of cover everything. All right, and that's it. And